Hey everyone, welcome. Ready for another deep dive. Today, we're tackling the core tools that are driving a lot of modern web development. We've got this awesome study guide and cheat sheet breaking things down, and we're going to try and make Node.js, Express.js, TypeScript, React.js, and Next.js, well, make them all make sense, especially if you're just starting out with this stuff.
Yeah, exactly. Think of it like getting a backstage pass to how a lot of the websites and apps you use every day actually work. We'll
Yeah.
pull out the most important parts, the concepts, so you can really see why these technologies matter.
I like that, a backstage pass. Okay, so first things first, Node.js. Now, the name might sound a little intimidating, but really, Node.js is all about letting us run JavaScript code outside of a web browser.
Right, like for a long time, JavaScript was pretty much stuck inside your browser, making websites interactive and all. But Node.js came along and said, hey, what if we could use JavaScript on the server side of things too? And to do that, it uses Chrome's V8 engine, which is super fast.
It's like JavaScript broke free from the browser, right? And that was a pretty big deal. It meant developers could use one language JavaScript for both the front end, the stuff you see on a website, and the back end, all the behind-the-scenes logic and data handling.
Totally. It streamlined things a lot. And one of the things that makes Node so powerful is its architecture. It's non-blocking and event-driven. Might sound like jargon, but stick with me. Imagine you're waiting in line, right? In an old-school blocking system, you'd have to wait for the person at the front to be completely finished before the cashier could even look at you.
Makes sense.
But with Node, it's different. If one task is going to take a while, like fetching data from a database or something, Node.js doesn't just sit there and wait. It jumps to handling other requests, other people in line, and then comes back to the first one when it's ready. So it's like a super efficient multitasker.
So it's not getting blocked by slow tasks. It's keeping things moving, doing what it can while it waits for other things to finish up. Okay, that makes sense. And the event-driven part.
Yeah, that just means it reacts to things happening, like you clicking a button on a website or data coming in over the internet. It's all about responding to events.
So this way of working, this non-blocking, event-driven architecture, is one of the big reasons Node is so good at handling lots of connections at the same time. It's perfect for things like chat apps or APIs that lots of people use all at once.
Right, exactly. Like imagine a chat server. You've got people sending messages, joining, leaving, all happening at the same time. Node can handle all that without breaking a sweat.
And to make things even easier for developers, Node.js comes with this thing called NPM.
Ah, yes, NPF, Node Package Manager. It's like a giant online store for code.
Okay, like an app store, but for code.
Exactly. Developers can find and download pre-built tools and packages that other people have created. Need to handle user logins. There's probably an NPM package for that. Working with dates and times. Yep, there's a package for that too.
So it's like, instead of reinventing the wheel every time, developers can grab these ready-made solutions and build their applications faster. That's really smart.
Yeah, NPM has been a game changer. It's helped create this huge ecosystem of shared code, making development way more efficient.
Awesome. And one last thing about Node, it's cross-platform.
Oh yeah, that's a big one. It means you can write your code once, and it'll generally run on different operating systems, Windows, Mac OS, Linux. No need to rewrite it for each one. Super convenient, especially if you're working on a team where people might be using different kinds of computers.
Okay, so in our study guide here, we have a little example of a basic Node.js server. It starts by importing this thing called HTTP module. What's that all about?
Right, the HTTP module. It's like the heart of Node.js when it comes to making web servers.
Yes.
It's what gives you the tools to, well, create the server and handle all those requests and responses that fly back and forth between the server and a browser.
So it's like the foundation for communication over the internet?
Yep, exactly. It's like the language that servers and browsers use to talk to each other.
Okay, so we import the HTTP module, and then we use this thing, http.createServer, to actually build the server itself. And inside that function, we have this bit of code that deals with incoming requests, we call it rec, and outgoing responses rests.
Yep, the classic request-response cycle. It's how the web works. A browser sends a request, like, hey, give me the content of this page, and the server sends back a response, like, okay, here's the HTML, CSS, and JavaScript you need.
Makes sense. And we see this line, status code, 200. What's that all about?
Ah, yes, the status code. 200 is basically a signal that says everything's okay. It tells the browser that the request was successful and the server is going to send back some content.
So like a green light for the browser?
Exactly. There are other status codes too, like 404 for page not found or 500 for server errors.
Interesting. And we also see this part, rest.setHeader, content type text plain.
Right. That's just telling the browser what kind of content to expect.
Mhm.
In this case, it's saying, hey, I'm sending you plain text, not HTML or an image or anything fancy.
Got it. And then there's this line, rest.n, hello, world.n. This is where the magic happens, right?
Exactly. That's the line that actually sends the hello world message back to the browser. It's what the user will see when they visit the server.
So if someone types in the server's address, usually something like localhost 3000 while testing, into their web browser, they'll see hello world displayed on the page.
You got it. It's a simple example, but it shows the fundamental request-response flow of a web server.
And lastly, we have server.listen 3000. What's that doing?
That's starting the server and telling it to listen for connections on port 3000. The port number is like a specific channel that the server uses to communicate, and you usually get a little message logged to the console confirming that the server is up and running.
Okay, so that's a basic Node.js server. We're using the HTTP module, setting up a server, handling requests and responses, sending back some text, and listening on a specific port. Pretty cool how that all works.
It is pretty cool how these basic building blocks come together to form the backbone of the web.
All right, so Node.js lays the foundation. But as you start building more complex web applications, things can get a bit messy if you're dealing with all those low-level details of handling requests and responses directly.
Right. It can get pretty tedious writing all that code from scratch every time.
Yeah,
And that's where Express.js steps in.
Express.js. Okay, so what exactly is Express.js bringing to the table?
You could think of Express.js as a toolkit, a framework built on top of Node.js. It doesn't replace Node.js, but it makes building web applications a lot more organized and efficient. It's what we call minimal and flexible.
Okay, minimal and flexible. I like that. What does that actually mean in practice, though?
Minimal, because it focuses on giving you just the core features you need to build web apps without a ton of extra stuff.
Mm-hmm.
And flexible, because it lets you structure your application in different ways and use other tools and libraries alongside it.
Got it. So it's like a streamlined foundation that gives you the freedom to customize as needed. Cool. So what kind of specific powers does Express.js give us?
Well, one of the big ones is middleware support. Now, middleware might sound kind of abstract, but picture it like this. Every incoming request to your application has to go through a series of checkpoints before it reaches its final destination, kind of like going through airport security.
I can picture that.
Each piece of middleware can do a specific task. It might check if you're logged in, or it might log information about the request, or even modify the request in some way before it moves on to the next checkpoint.
So each piece of middleware is like a little gatekeeper doing its job before letting the request pass through.
Exactly. And this can be super helpful for organizing the logic of your app and making sure things happen in the right order.
Then you've got routing capabilities. This is all about handling different web addresses, like your home page, that's usually just a slash or an about page, or product listings.
Right, so different URLs within your website lead to different content.
Yeah.
Express.js makes it really easy to define these routes and say exactly what should happen when someone visits a particular URL. Remember in that basic Node.js example, we had that server.listen thing?
Mm-hmm.
Well, in Express.js, you'd use app.listen to start the server. It's basically doing the same thing, but Express.js just makes it a bit cleaner and easier to work with.
Okay, so it's building on those core Node.js concepts, but making them more manageable for building web applications. Cool. And I see in our cheat sheet here that we've got an Express.js version of that Hello World example. What does that look like?
It's pretty straightforward. You start by importing const express requires express, and then you create an instance of the app, const-app.send.
Right, we're bringing in Express and then creating an app.
Yeah, and then you define the route for the home page, like this .app.get,
Right.
rows.send, hello world. This tells Express.js, hey, when someone makes a GET request to the root path, just the slash send back the response, hello world.
So it's doing the same thing as that Node.js example, but with a lot less code?
Exactly. Express.js is handling a lot of the behind-the-scenes stuff for you, making things much simpler and more readable.
It's like Express.js take the wheel.
Pretty much. It lets you focus on the logic of your app without getting bogged down in the low-level details.
All right, I'm liking Express.js. It sounds like a real time saver. Okay, so we've got Node.js for running JavaScript on the server and Express.js to make web app development on Node.js smoother. Now, what about TypeScript? I'm a little confused. We're already using JavaScript. Why do we need another language?
Haha, I get it. It can seem a bit redundant. But TypeScript isn't really a completely different language. It's more like JavaScript with superpowers.
Okay, JavaScript with superpowers. I like that.
It's a superset of JavaScript, which means it takes everything that JavaScript has and adds some really useful stuff on top. The main thing it brings is static typing.
Static typing. Okay, that sounds kind of technical.
It is a bit, but it's super helpful. In regular JavaScript, you don't have to specify what type of data a variable holds. It could be a number, a string, an object, whatever. And that flexibility can be nice sometimes.
Yeah, it can be pretty loosey-goosey.
Right, but it can also cause problems, especially as your code gets bigger. Because if you accidentally mix up types, like trying to do math with a word instead of a number, you might not find out until your program is running, and then it could crash or do something weird.
So it's kind of risky, like walking a tightrope without a safety net.
Exactly. And that's where TypeScript comes in. It lets you specify the types of your variables, like saying this variable will always be a number, or this function will always return a string.
So it's like adding labels to your data. Makes sense.
Exactly. And the cool thing is, TypeScript can catch these type mismatches before you even run your code. It's like having a spell checker for your code that catches logic errors related to data types.
That sounds super helpful.
Yeah.
Less debugging later on.
Oh yeah. It can save you a ton of time and frustration. And it makes your code more reliable and easier to work with in the long run, especially if you're working on big projects. And aside from static typing, TypeScript also gives you other cool things like interfaces. We've got an example here. Interface username.string, age.number. What's going on there?
Okay, an interface. So it's like defining a blueprint.
Exactly. It's saying, hey, if we want to create a user object, it needs to have these specific properties. A name that's a string and an age that's a number. It's like setting up a template.
So you're defining the structure that a user object should have. Got it. And then we have this greet function, ref user.string, return. Hello, user.name. What's with the .user and .string in there?
Those are type annotations. They're basically telling TypeScript what types of data we're working with. Your user. It means this function expects its input, the user, to follow the structure we defined in the user interface.
Right, so it has to have a name and an age.
Exactly. And the .string at the end means this function is going to return a string of text. If you try to pass it something that doesn't match the user interface, or if you try to make it return a number instead of a string, TypeScript will flag it as an error.
So it's enforcing those rules, making sure we're using the right types of data in the right places. That's really neat.
Yeah, it adds a whole layer of safety and consistency to your code. And in the last part of the example, we create a user object, const user, user name, Alice out, age 25. Again, we're using .user to say that this object should follow the rules of our user interface. And finally, console.log. Users will print, hello, Alice, to the console.
Okay, so TypeScript is like a super-powered version of JavaScript. It adds static typing and other features to help us write safer and more predictable code. I'm getting it.
Exactly. While you do have to compile TypeScript code into regular JavaScript before you can run it, the benefits you get in terms of catching errors early on and writing more maintainable code often make it well worth the extra step.
All right, we've got a pretty good toolkit going now. Node.js for server-side JavaScript, Express.js for streamlining web app development, and TypeScript for adding some extra safety and structure. Now let's switch gears and talk about the front end, the part of a website or app that users actually see and interact with. That's where React.js comes into play. What's React all about?
React.js is a JavaScript library that's specifically designed for building user interfaces. It's really good for making those interactive dynamic elements you see on modern websites.
Okay, so like those drop-down menus, buttons that do stuff when you click them, things that change without having to reload the whole page.
Exactly. And it's especially great for building single-page applications, or SPAs. Those are websites where you can click around and navigate to different sections without the whole page reloading.
Ah, like social media feeds where you can scroll and scroll without having to wait for a new page to load every time?
Yep, exactly. React helps make those experiences super smooth and responsive.
Cool. And I hear a lot about React's component-based architecture. What does that mean?
It means that instead of thinking of your entire user interface as one giant chunk of code, you break it down into smaller, self-contained pieces called components. Think of it like building with Legos. Each brick is a component, and you can put them together in different ways to make more complex structures.
I love that analogy. So you might have a component for your navigation bar, a component for a product card, a component for a user profile, and so on.
Yep, exactly. Each component manages its own little piece of the UI, and you can reuse them throughout your application. This makes it much easier to handle complexity and build consistent-looking interfaces. And it makes it easier for teams to work on different parts of the UI at the same time without stepping on each other's toes.
That's a really smart approach.
Yeah.
Okay, so components are a big deal in React. What else makes it so powerful?
Well, another key thing is the virtual DOM. It's basically a clever optimization that helps React update the user interface really efficiently. When something changes in your application, React doesn't immediately update the actual structure of the web page, the real DOM. That can be a bit slow.
So what does it do instead?
It creates a lightweight copy of the DOM in its memory, which is called the virtual DOM. Then it compares this virtual DOM to the previous version and figures out the most efficient way to update only the specific parts of the real DOM that have actually changed.
So it's like finding the differences between two versions and only changing what's necessary. Smart.
Exactly. And that makes updates super fast and smooth, which leads to a much better user experience.
Okay, virtual DOM for efficiency. Got it. And in our example here, we have this basic functional component in React called counter. Let's break that down. What's happening in that code?
All right, so this counter component is a simple example of how to manage dynamic data in React using something called a hook. You see that line at the top? Import React, use state from React. That's importing a special function from React called useState. Hooks let you add state variables to functional components.
Variables.
Yeah. State in React refers to data that can change over time and affect what's displayed in the UI. Like in our example, the counter's value is a piece of state.
Makes sense. So when the user clicks a button, the counter goes up, and that changes the state of the component.
Exactly. And the useState hook helps us manage that.
So what's happening in this line? Const count, set count, useState 0.
Okay, so useState 0 is doing two things. First, it's creating a state variable called count and setting its initial value to 0. Second, it's giving us a special function called setCount. It's the only way we're allowed to update the value of count.
Why do we need a special function for that?
It's how React keeps track of changes to state. Whenever you call setCount, React knows that something has changed, and it triggers a re-render of the component to reflect the new state.
Okay, so we've got our count variable, and we use setCount to change it. Got it. And then we see this line. You clicked count times. That looks like HTML inside our JavaScript code. What's going on there?
Ah, that's JSX. It's a special syntax extension that lets you write HTML-like structures directly within your JavaScript code. React uses JSX to describe how the UI should look.
So it's a way to write something that looks like HTML but actually gets turned into JavaScript that React can understand.
Precisely. And those curly braces, count, are how you insert the dynamic value of the count variable into the JSX. So each time the count changes, React updates what's displayed on the screen.
That's pretty slick. And then there's a button with an on-click handler button, on-click, set count +1, click me button. So what happens when we click the button?
When you click the button, that code inside the on-click handler runs. It calls setCount with the current value of count +1. So every time you click, the counter increments by 1.
And React sees that the state has changed thanks to set count, and it re-renders the component to show the updated count. I'm starting to see how all this fits together.
It's all about managing state and how changes to that state affect what the user sees. That's a core concept in React.
Okay, we've explored the basics of building front ends with React. Now, what about Next.js? The name kind of implies it's like the next step or evolution. What exactly is Next.js, and how does it relate to React?
You can think of Next.js as a framework built on top of React. While React gives you the fundamental tools to build user interfaces, Next.js provides more structure and adds a bunch of features that are super useful, especially when you're building applications for real-world use, applications that need to be fast and show up properly in search results.
I've heard that Next.js is really good for SEO, search engine optimization.
You're right. And one of the reasons for that is server-side rendering. Remember how we talked about React usually rendering stuff on the client side, meaning in the user's web browser?
Yeah, the browser downloads the code and then runs it to build the UI.
Right. Well, Next.js gives you the option to do server-side rendering, where the server does some of the work up front. It pre-renders the React components into plain HTML before sending it to the browser.
So it's like doing some of the heavy lifting on the server instead of making the browser do all the work.
Exactly. And that can lead to faster initial load times, which is great for users, and it makes it easier for search engines to understand the content of your pages, which is good for SEO.
Makes sense. Everyone wants their website to load fast and be found by search engines. And speaking of speed, Next.js also has this thing called static site generation, or SSG.
Ah, yes. SSG is all about pre-building your pages as static HTML files. So if the data for a page doesn't change very often, like a blog post or an about page, Next.js can generate the HTML at build time. Then when someone requests that page, the server can just serve up the pre-built file. Super fast.
That's awesome. It's like having a website that's already built and ready to go.
Pretty much. And it's great for performance and scalability because the server doesn't have to do as much work each time someone visits the page.
Makes sense. All right, server-side rendering and static site generation for speed and SEO.
Got it.
Our study guide also mentions file-based routing. What's that all about?
This is one of the things that makes Next.js really easy to use. In a typical React app, you often have to set up routing using a separate library and configure how URLs map to different components. But Next.js keeps things super simple. It uses file-based routing, meaning the structure of your pages directory directly determines the routes in your app.
Okay, so if I have a file called about.js in my pages directory, that automatically creates an about route.
You got it. No need for any extra configuration. Super intuitive.
I like it when things are intuitive.
Yeah.
And there's one more thing we need to cover, API routes. What are those?
API routes let you create backend functionality directly within your Next.js application. So if you need to fetch data from a database or handle user authentication or anything like that, you could do it all within the same Next.js project. No need to set up a separate backend server.
So Next.js can handle both the front end and the back end. That's impressive.
Yeah, it's a really powerful feature, especially for full stack development. You can build your entire application, front end and back end, using JavaScript and React all in one place.
Awesome. So to get started with Next.js, we just run a few commands in our terminal, right?
Yep. The example shows you the steps. You run npx create next app my next app to create a new project. Then you navigate into that directory and run npm run dev to start a development server. And just like that, you've got a basic Next.js app running.
Nice. And then if I want to create a new page, I just make a new file in the pages directory and Next.js automatically handles the routing.
Exactly. File-based routing in action.
Okay, so to wrap this all up for everyone listening, we started with Node.js, the foundation for running JavaScript on the server side. Then we moved on to Express.js, a framework that makes it easier to build web applications on top of Node.js. We explored TypeScript, which adds static typing and other features to JavaScript, making our code more robust and predictable. Then we jumped into the front end with React.js, a library for building dynamic and interactive user interfaces. And finally, we covered Next.js, a powerful framework built on top of React that brings server-side rendering, static site generation, file-based routing, and API routes to the table.
That's a fantastic summary. And all of these technologies are interconnected in the real world. You might find a Next.js front end built with React, maybe even using TypeScript, and then a back end powered by Node.js and Express.js all working together to deliver a web application. It's a pretty amazing ecosystem.
It is. And we know a lot of you are listening because you're interested in getting deeper into these technologies, maybe building your own web applications.
Absolutely. And for those who want to really dive deep and get personalized guidance, maybe through one-on-one training or some consulting, we wanted to mention that the folks at https://www.strogenie.com can help. They've got experts who can guide you through those learning journeys.
Awesome. We'll be sure to put a link to that in the show notes. So, our final thought for everyone today. Think about how all these technologies, these building blocks, work together to create the web experiences you use every day. What part of this deep dive really sparked your curiosity? What do you want to explore further?
The world of web development is constantly evolving. There's always something new to learn.
Yeah, exactly. So keep exploring, keep building, and thanks for joining us on this deep dive.